and integration also having a different graphical meaning, which is the area. Now, in the other case, we have learned up to now that mainly about integration, which is a process you can't conduct for all the given functions. But you have to remember, if a function is well defined, we can draw a graph. But mathematically, some functions are hard to integrate. With the definition, if you just revise the previous lessons, I repeatedly mentioning that we have set of formulae for the integration. Only those formulae can be used for the integration. All right, that means if you are uh, simplifying an integration question, that means you what you are doing is given statement is rearranging uh, to compatible with given formula, then only we can integrate. If it is hard to simplify to change the form to a given formula, then you know it's very hard integration question. But in your textbooks, limited forms are given which are quite easy to integrate, but some advanced applications are there when you are doing something, some activities in practice, because some function is given to integrate. It's a practically important or practically applying function, right? If you want to integrate, that means for some purpose we want to find the area of the graph. For that you have to integrate. That is the basic principle you have to find the area. But if that practical function is hard to integrate, then we have to have some other method, right? This trapezium rule is a method to get approximation for the integration. Since the integration is area under the graph, this trapezium rule is giving some approximation value for the area under the graph, right? Therefore, after using trapezium rule, what you can get, something close to or approximation to the integral or the integration, because you know if it is finite integration, we are going to have a value. That value, as I mentioned here, that value is the area, right? Now you have to remember that for that only we are using trapezium rule. Trapezium rule can write trapezium rule can be used to find trapezium rule can be used to find an area under the under a graph, under a given graph. Approximately by dividing by dividing by dividing the given area by dividing the given area into by dividing the given area into few number of strips, few number of strips. Okay, Dion. We should have to have good idea about which I have explained in the note there. Right now, you have to have clear idea about the difference, right, between integral answer and trapezium rule answer. Both are giving us the area of the graph, right? At the same time, they are different because integration will give you the exact value for the area under the graph. But when you come to the trapezium or trapezoidal rule, in that it is a approximation, right? Underline that word approximately. It will give only the value approximately. But as I mentioned earlier, since some functions are hard to integrate, trapezium rule may be the only method we are having to find the area. Okay, now in that sense, trapezium rule or trapezoidal rule is really important and uh, in practical purposes, right? I will just draw a diagram and show you. Suppose we have a graph like this. Uh, right, for a given period of x values, uh, a and b are the limits x, this is y, right? In here, as I mentioned in that above sentence, we are dividing this area into strips. Now you have to remember, when number of strips are high, accuracy of the value you are getting for the area is high. If number of strips are less, accuracy for the area is also less, right? Let's take this one by taking two strips only. We are taking here, this is the midpoint of a plus b, a and b. We are dividing this one, right? I will use different color for that. Right, then you can have a trapezium by interconnecting these two, and for this you will have a trapezium like this. Okay, then areas, one is this. If you take this trapezium and this trapezium, the other one, now you can see almost the total area will be covered by these two trapeziums, right? Here we can take this as y1, that is the value we are getting for a, right? Oh, I will write the by using notation. If y is given as some function fx, this should be fa, right? This is the uh, draw it more clear by taking. Then this is y2. This is y3. Right? Uh, Now clearly you can see these two areas will be covered the area under the graph. Most probably if you add these two areas, that should be very much similar to the area under the graph. But we have, if you check carefully, we can see two parts of area of the small amount of the area is not included for the areas of the trapezium. Those are this part. That's why I asked you to underline that a word approximately, because this trapezium rule will only give the approximation for the area of the graph, because this redly colored parts, redly shaded parts are not included for the area of the trapezium, but they are included for the area of the function, right? I think you can understand the idea. Can you draw this one? Here you can write two strips are used. They will give the number of strips, right? Two strips are used. Draw this one.
Okay, sir.
Okay. Okay. Uh, I will prove there's a given formula which is using for this purpose to find the approximation area, right? But with this example, I will write, I will derive a formula when two strips are there. Then I will give the standard formula for the trapezium rule. Uh, After comparing both, we can see trapezium rule can be derived geometrically because these are two uh, things. Now, as I have mentioned, you can see this length from here to here is y1. This length here to here is y1, here to here is y2, and here to here is y3. Now, what is this here to here length? This b minus a, and this length is b minus a. This is half of that, therefore b minus a divided by 2. Here b minus a divided by 2. Right? Then if I write something for this trapezium, I can say, I think you can see this up to this point, right? Uh, Therefore, what you can say is area should equals uh, area of this A1 plus A2, A1 plus A2. Then uh, what is A1? Since this is a trapezium, you know that it should be. I will take this as H, right? Here to here. This I will take as H. Then you can say A. You know this is a trapezium. Therefore, y1 plus y2 divided by 2. If you have a trapezium, area is addition of two parallel sides divided by 2 into the perpendicular distance. Now these angles are 90 degrees. Therefore, this distance is the perpendicular distance, that is h into h, right? Plus this one y2 plus y3 divided by 2 into again h, because same thickness I have been used to divide, right? Then I can have this. Here h is common and 2 is common. Therefore, here also we have h and 2, which I can take out as h over 2. Then you have y1 plus y2 from here. Here you have y2 plus y3 for the second term. What I did was I have taken this as a common factor since both are having this, right? HO2. Then we can see that is HO2 y1 plus 2y2, right? Plus y3. Okay, for two strips, this is the formula, right? When we have many strips, I think you can understand if you draw thin strips, what will happen? This area, red colored area, will be less. I will come to that. First, write this one up to here. Draw this one, and you have drawn this, and put these values, right, and write this one up to here. This one is the formula you are going to have the area. This is area, right? Finally this should be the area. This for area, right?
Okay, sir.
Okay, right. Do you can understand this, ne?
Yes.
Okay, okay. Now, when you come to here, then I will move to the standard formula they have given. Uh, ca- uh, can you understand that if you now just understand this, because they are not going to ask questions about this, but if you are learning some new thing, uh, it is very useful. Even though it's a mathematical application, if you understand and apply them, it is very important for your future studies. Therefore, what I will what I want to explain is, just try to understand. If you increase the number of strips, right, what will happen is this redly shaded area will be less. We are using this method to find the area of the graph, right? What we did was we have divided this one into two strips. But in that case, we have observed that this red color, redly shaded areas are not included for the areas of these trapeziums, but they are there for the area under the graph, right? That is the error we have. But what will happen if we use three strips? Now here we have only two trapeziums or two strips. But if we divide this one into three strips, then we have to put more terms here. But if you draw that one graphically, you can understand that if you increase the number of strips, if you introduce more number of strips, the error red part area will be less. That means our value is going to more close for the total area, right? I will just draw a diagram and show you, but I'm not going to prove this one for the three strips, four strips. Like what I will do is I will give the standard formula for the trapezium rule. After this is that standard formula is in form of this, but we have more terms as I mentioned, right? But I just want to show you, if we are using more than two strips, let's say it's three strips. In that case, I can show you that error will be less. Suppose we are taking three equal strips for this, right? In that case, if you complete the trapezium, you have to draw lines like this. You can see, right? Then can you observe this missing area, this red colored part? Compare to this red colored redly shaded part will be less if you divide this one into three strips. That means when we are increasing the number of strips, error will be less. Okay, right. Uh, you can write by putting a star mark by increasing the number of trapeziums. You can put a star mark and write by increasing the number of trapeziums. Value getting from the value getting from the trapezium rule is more close to the area of the graph. Right. This is the brief explanation. Don't write. This is the brief explanation about trapezium rule, and I just want to compare that with finite integration or definite integration. That means integrations with limits. As you know, integration with limits will give you the area. Now, both of you can understand that, right? Now, then, at the same time, some functions are really hard to integrate. Yes, you can see the function, you can draw the graphs, but since integration is a mathematical process, some functions are very hard to integrate. That means it is very hard to convert to the nature of the formula. In that case, uh, if you want to get at least a approximation for the integration, this method can be used, which is called as the trapezium rule. In here, what we are doing is we are dividing the given area to trapeziums with equal widths, right? Then geometrical method will be used to find the approximation for the given area, right? Then I will give the standard formula which is in this shape, but as I mentioned, number of middle parts should be greater, right? Uh, you can write in a new line, again you can put a star mark and write general formula for the trapezium rule. General formula for the trapezium rule can be given as general formula for the trapezium rule can be given as this, right? Area. Area is, you know that this, right? Always area is the finite integration. A to b fx, right? Dx. Because area is, you know that from the other side it is the integral. Is the area, that is the integral. But I can't say it's equal because you can see integration which give the exact area, but trapezium rule gives without these red parts. Therefore, you can't say this integral that is at the exact area is equal to this, but you can say they are kind of approximation to the expression we are getting from the trapezium rule, which is what I will give the statement h over 2 into h is the thickness into y1 plus 2 times because you can see if you take h over 2 here, 2 times middle parts are having 2 times. I will put square brackets for this. 2 y 2 y 3 up to yn minus, can you see if you have 3 strips here, give me 1 second, in their standard formulae, now Dion, I asked you to change something. The other person, you can, Ahmad, you can take the note from the Dion, right? Now here, when they are making the standard formula, I just noticed now they have taken this as y naught, right? Sorry about that. This is just a notation. Don't worry about that. This is y naught. This is they have taken as y1, and this is y2. Then if number of strips are 2, here y2. If number of strips are 3, here y3. Likewise it comes, right? Sorry about that. Then this beyond this should be changed because I just want to show this is a part of the standard formula. Therefore, this becomes y naught and this becomes y1 here. This becomes y1 and this becomes y2. Then again this becomes y naught and this becomes y1. This becomes y1, this becomes y2. Sorry about that. This is y naught, this is y1, this is y2. It's a notation, don't worry, because they have taken this first one as y naught here. That's why this have started with y naught, y1, y2 up to yn minus 1, because if you have n strips, if you have if you have 2 strips, this is 1, like this. If you have 5 strips, this is 4, plus finally we have the last one, y n